World here. What's up? I hope you are doing well. In the previous video I told about the integral forms derivations equations, and in this video I am going to derive the first equations of the four differential equation, that is divergence of d is equal to rho. So without wasting the times, I just want to start the video. The intro part was removed because you are very much aware of that. If you don't watch those kind of previous video, then go and watch it first. Okay, then I'll start this. So don't worry about the notes I say. WhatsApp channel is there. You just have to join that. Okay. So yeah. So what is the first equation? The divergence of d is equal to rho. What is that? The divergence of d is equal to rho. So sorry, rho. So what is the d? D is the displacement density. And what is the relation between displacement density and electric field? That d is directly proportional to the electric field, and d is equal to epsilon naught E. So this is the relation. And what is the E naught? E naught is the permittivity in the free space. E naught is the permittivity in the free space, and displacement charge displacement density directly proportional to the electric field. Okay, so this is the relation, we know it. So to derive this first equation, what we know, it is based upon, there are four laws, four equations for four laws. First law is based upon that Gaussian law for the electrostatic. What are the first equations? First equation depends upon the Gaussian law for the electrostatic. So what is the Gaussian law for electrostatic? The second is for magnetostatic. Okay, so what is the law states that? So you know it in the 11-12 standard, that is Gaussian law states that surface integration of E dot ds is equal to q upon epsilon naught. So what does it mean? That means the electric field passing upon that surface area, that particular surface area, is equal to q upon epsilon naught. Okay, so this is the principle, we can say this is the law. I told this mathematically. Okay, so if we took the epsilon naught to this side, then what will happen? Let's say, so we have to get the divergence symbol. How can we do the divergence symbol? Okay, we'll do in the next step. So this epsilon naught will go to this side, and it will be E naught dot ds. Okay, is equal to here is q, and to know the q, q is equal to, actually in the volume charge density, it is rho dv, the volume charge density, and this is the formula for q, it also. There is a derivation, but it is not very much important, just it, that q is equal to this much. So we can write in the place of q for that. In the place of q we can use that, and for this we can use d. Okay, so here surface integral of, it is the displacement density, that is d dot ds is equal to q is equal to volume integral of rho dv, as q is this much, as d is this much. That's why I replace. Okay, that's why I replace. This is the reason. That's why I replace this kind of values. Okay, so what happens in the next stage? In the next stage, we just have to get the divergence symbol here. We have to get the divergence symbol. So how can we get the divergence symbol? We just use some special theories we will use. So what are the special theories? At first I say that is the Gaussian divergence theorem. What is that Gaussian divergence theorem? Gaussian divergence theorem. So what is the role of Gaussian divergence theorem? It will convert the surface integral into volume integral, and the volume integral into surface integral. Do you know it or not? When the volume integral, it is with the divergence symbol, it will vanish out when it comes to the volume to surface. When it comes to the volume to surface, it vanishes out. But when it comes to the surface into volume, it will again come. If the first state it is vanished out, it means in the next state it will again come. That means in case of the volume integral, it will converted into divergence of d. Divergence of d dot, the close symbol will be vanished out because volume is already a closed symbol, that's why. So what will happen here? Here it will be dv is equal to, in the LHS side I just use it because in the right side already it is dv, because we just want to take dv in the single side, that's why. b, this is rho dv. Okay, here also dv, here also dv. So coming to in the single side, then it will be volume integral of divergence of d minus rho whole dv is equal to 0, because it comes to the left hand side. Okay, in the next step what will happen? In the next step, here if you took this much of common, then it is divergence of d minus rho, it will, the constant will be removed out, and it will be volume integral dv, that's equal to 0, and this much is v, this much is v. Integration of dx is equal to x, integration of dx is equal to x. Okay, that's why here with respect to x also, here also it will be v. So it will be, when go to the right hand side, it will be 0. Then we can say divergence of d minus rho is equal to 0 implies divergence of d is equal to rho. So this is our required equation. So this is our required equation we got from. So it is very simple. It is very simple if you look at on that eye. If you look at other eye, then it will be very difficult. Okay, it depends upon you how it is. Write in the comment section. Okay, share this channel, subscribe this channel. Don't forget to comment your doubts. I'll answer it. And how it feels you also write out, because your comments are very important to me. So here I end my video. In the next video I will derive this equation. Thanks you for watching this.